Hello, good morning, everyone. So, in the previous class, we started with the EIGRP protocol and we discussed about successor, feasible successor, so advertised distance, and we also discussed about feasible distance. So advertised distance, we also call it as a reported distance as well. Don't confuse with administrative distance. So administrative distance is used to find the trustworthiness of a particular route. Now, what do you mean by successor? Yes.
Best path, sir.
Okay. Loop free. Best path. To reach the destination. Present in the routing. Very good. Okay. And it is only present in the routing table. Good. What about feasible successor? It is also a loop free
path.
Yes.
If primary went down, then it will go to the
Backup,
second.
but it is also loop free. We call it as second best path or backup path to reach the destination. So what about advertised distance?
Neighbors distance to the destination.
Very good. It is the neighbors distance to the destination. What about feasible distance? So total distance successor to from source to destination. So these things we discussed in the previous class. So now, if we talk about the successor, it is the primary path to reach to the destination. So successor is present in your routing table. When you will find the successor in your topology table, from the topology table, only the best path will be installed in your routing table. What about the feasible successor? It's a backup path. Where you will find the feasible successor? Only in the topology table. You will not find the feasible successor path or the backup path in your routing table. Only the best path, that is your successor, is installed in the routing table. So advertised distance, it is the neighbor's distance to reach to the destination, and feasible distance, it's the total distance. Now, we're talking about feasible successor. Yes, only present in the topology table. Now, then we discussed about feasibility condition. Why you require this condition? Yes. What do you mean by feasibility condition? Correct. To elect the
Feasible success.
Yes. Can you tell me what is the feasibility condition?
Advertisement distance should be always less than the FD value of successor.
Very good. It is advertised distance of feasible successor should be less than feasible distance of the successor. Clear? Then we discuss about the packet types. We discussed about the hello packet. We have update. We have query. We have reply. And we have acknowledgement. We have SI query, SI reply. What is the by default hello and hold time in EIGRP? Hello is 5.
If
What about hold?
15.
15 seconds. Okay. Why we use hello packet? To establish and maintain the adjacency. So every 5 seconds, the router will send a hello packet. What about update packet? To exchange the routing information, use update packet. What about query? When a router will start querying. Very good. When there is no feasible successor in the topology table, then the router will query for a second best path. What about reply? It is sent in response to a query. Why? What about acknowledgement? Since EIGRP is reliable, so if update, query or reply or SI query or SI reply, will get an acknowledgement back just for reliability purpose. And SI query and SI reply, we'll discuss it later. Now, then we discussed about the K values. How many K values we have?
Five.
5.
We have K1, we have K2, K3, K4, and K5. What K1 represents? Bandwidth.
Bandwidth.
Very good. What about K2?
Delay.
Load.
Load, not delay. Delay is K3. And reliability we have. And K5 represents MTU. So by default, in the metric, we use only bandwidth and delay. Rest is kept as 0. And question is why? Why only bandwidth and delay? These are static values. Very good. Madan. What about K2, K4, and K5? These are dynamic values. What do you remember static and what do you remember dynamic? Constant over the period of time. Very good.
Reliability is what? How we can define reliability?
Congestion. If congestion is there in the network, no, your reliability will also change.
Okay.
How much reliable? Yes. So if we talk about dynamic values, yes, tell me.
What's the stand about constant over the period of time?
What?
What it mean by constant over?
Even if it is what you say, 24 out of 24 hours, you will see the bandwidth and delay, it will remain constant. It will not change. It's fixed, right? Bandwidth and delay, fixed values. These can change over time.
Okay.
Okay. Next, we discussed about the metric formula. What is the metric of EIGRP? Is the feasible distance. Least FD is the best path. So what is the formula? 256. I'm asking for the shorter formula. After implementing your K values, the formula will be 10 to the power of 7 divided by minimum bandwidth plus sigma delay by 10. So least FD is the best path. Clear? Till here we have discussed in the previous class. Now, today we'll be discussing about neighbor table, topology table, how to enable EIGRP, And we'll see equal cost and unequal cost load balancing. Okay, so now we'll start with neighbor table and topology table. So before that, we'll see how to enable EIGRP. Then we'll do a lab. Then we'll discuss about the components of neighbor table and topology table. Clear? Now how to enable EIGRP. So you have to go to the router, go to the config mode. So router, EIGRP, and the ASN value. ASN stands for autonomous system. Then you need to advertise your directly connected networks. Then we have no auto summary. So this no auto summary is by default disabled in the Cisco, in the iOS version 15.1. After iOS version 15.1, this is by default enabled on all Cisco routers. Yes, RTR means router. I'll show you in the lab. It will come RTR. So outer version 15.1, this is by default enabled.
Sir, why we need to use no auto summary?
Why? Because by default, EIGRP used to support only class full networks. Means, let us consider we have a network 172.23.0/24. Which class is this? Class C, right? So what EIGRP used to do, it never used to advertise this whole network bits. What it used to do, it used to just advertise 0.0/60 because it's class B, right? Correct. So it only used to support your class full networks. Class full. What am I class full? So we disable this no auto summarization. No auto summary means don't do by default summarization. Just whatever the networks I'm advertising, please advertise those networks only. No need to summarize automatically. Clear? Now we'll do a short lab. Take two routers. We have 192.168.12.0/24.2/32, and we have and we'll use ASN 12. And then we'll be seeing how to read the neighbor table and the topology table. Voice is breaking. Yes, online.
This is okay.
Okay, right. Okay. Done. Topology noted. Done. So we'll take two routers. So the IP address will be 192.168.0/20. Dot one. This is dot two. We have a loop back on R1. This is the autonomous system number. Right. Wait for the console. This is visible. Okay. Enable config. Host name R1. Interface 0/0. IP address will be 192.168.0.1/20. We have loop back 0. The IP address will be 1.1.1.1/30. Now, show IP interface. So I have assigned 0/0 with 12.1 and we have a loop back 1.1.1. Done. So go to R2 and assign the IP address. Interface 0/0. IP address will be 192.168.2/. Interface loopback 0. So the IP address will be 2.2.2.2/30. Mhm. Interface loopback 0. Show IP interface B. So 0/0 is assigned with 12.2 and we have loopback 2.2.2. Now we'll go and enable EIGRP on R1 and R2. So router, before enabling, just start the debug. Debug EIGRP packets. So router, EIGRP. So to mention the autonomous system number. So this is your classic mode. So what we are using is classic mode. We have name mode as well. We'll discuss it later. So okay. Right. And ASN must match on both the routers in order to form adjacency. So now, what about router ID? Tell me what do you mean by router ID? Yes,
Yes, router name.
router name, that is host name, right? I provided already the router name. Can you see it? This is your router name. What is router ID?
So loopback ID is router ID.
No, I'm not asking what is the loop, what is the router ID. I'm asking what do you mean by router ID? What do you understand by the word router ID? What is the significance of router ID? It is used to identify particular router. So if we talk about election criteria, in order to elect a router ID, first it will prefer the manually configured one. If the loopback is not manually configured, then it will check highest interface loopback IP. If loopback is also not configured, then it will take highest interface IP address. This is how your router ID is elected on a particular router. First preference is manually configured. Second preference, if it is not manually configured, then it will check the highest interface loopback IP. If loopback is also not present, then it will take the highest interface IP address. Clear? No?
Sir, what is highest interface loopback ID?
Let us consider I have one more loopback here. Then what will be the router ID?
The 11.
Yes, highest. Clear? Now. So when you can manually assign the router ID. How to do that? Using the command EIGRP router ID. 1.1.1. Or you can use any other value as well. You can use 2.2.2.2 or you can use 11.11.11.11 as well. Clear? And just to identify a router. Now, network. You need to advertise all the directly connected networks. So what are the directly connected networks for R1?
1 and 192.
Yes, it's 192.168.12.0 and network 1 dot 1 dot 1 dot 1. Can you see? It started sending hello packet. Send hello. Every 5 seconds, it will send this hello packet. Now, go to R2 and enable EIGRP. Router EIGRP 12. Go debug EIGRP. Router EIGRP 12.
So basically that debug will do all for all the
Yes, all
EIGRP
packets.
peers, right?
For all the EIGRP packets. Can you see here? If I do debug, it will do debug.
Oh,
For
so can we like if
You
we
can do
have
that, yes.
multiple
Yes,
EIGRP neighbors, can we do it for specific neighbor?
yes, you can do that.
Okay.
So EIGRP router ID will be 2.2.2. Enter. So network 92168.12.0. Enter. Then network 2.2.2.2. So they'll start sending hello packets. So once hello is received, it will send an update packet. Sending update packet. To be quick, otherwise you'll miss this. Just go up. First hello is sent. Hello will be sent every 5 seconds. Then they will exchange the update packet. Seen, right? Sending update, then received update. So both will exchange the routing information. Clear? Now, first command, show IP EIGRP interface. So this command will show you where all you have enabled EIGRP on. Enter. So I have enabled EIGRP on Z0 bar 0 and on the loopback 0. Show IP EIGRP interfaces. This will discuss what by SRTT and neighbor table. So we go and check on R2, show IP. Show IP EIGRP. This is a command that is used to see on which all interfaces you have enabled EIGRP. I have enabled EIGRP on Z0 bar 0. That is your exit interface and on the loopback. Now, how to check the neighbor adjacency? Show IP EIGRP neighbors. This command will show you the EIGRP neighbors. So now you need to understand the components of this command. Now, so H stands for handle. Please make a note. Handle. This will tell you the order of EIGRP adjacencies formed. That stands for handle. Order of adjacency means, so 0 means I have formed the adjacency first. Then if there is one more router, then it will show it as 1. So it will show you the order of adjacency. No? Done? This is the neighbor IP address. This is the exit interface. Now, this is the hold on time. By default, hold on time is 15 seconds. So what do you mean by hold on time? Why you require hold on time? Okay. So this is time you need to wait before declaring the neighbor as dead.
But here it is showing us 11 seconds, right? So here time is
every 5
11
seconds you will get an update, right? As soon as you get an update, what is it? As soon as you get a hello packet, it will reset to 15 again. I'll show you 1 minute. So once this hold on timers expires, then it will remove the route from the routing table. 1 minute. I'll come back to hold on time. Now, what do you mean by uptime? This will show you how long your neighbor adjacency is up. Adjacency is in up state. Done?
Yes, done, noted.
Often guys are noting it. 1. Done? You know? Okay. Next field, SRTT. SRTT stands for smooth around, sorry, trip time. So it is a time required to send an EIGRP packet and receive an acknowledgement back. So which are the reliable packets in EIGRP? How many reliable packets we have? Update query, reply, SI query, and SI reply. So we have 5 reliable packets. Next field is retransmission timeout. Not your RTO office. Retransmission time. So this is the time. That an EIGRP router needs to wait before retransmitting. Needs to wait before retransmitting. Yes.
Sir, that means if it has not received an acknowledgement in that 100, then it will retransmit. Is it?
Yes. Any packet, not only. So if there is any value in Q count, no? So before retransmitting, it needs to wait these many seconds and then only it should retransmit. This is your Q count. What do you mean by Q count is this field you need to see always 0. If you see any value here means there's a problem with your adjacency or there is a congestion in the network, you will see a number here. This should always be 0. So let us consider we have a number 2. Then these packets needs to be resent again. So that this is the timer. Timeout means it should wait for 100 seconds before retransmitting these packets which are present in the queue count. So this is your sequence number. So this sequence number, this is the number that will represent your last EIGRP packet, whether it is a query, reply, or an update.
Can you again tell that last?
Sequence number. So this number, what it will represent it is a last, what is a packet received, means either whether it is a query, reply, or a update. Last packet received. Sequence number.
No, is 4 number designate something or what?
No, nothing it requires. Just it is notifying that 4 times it has exchanged.
Okay, 4 times.
This update, yes. Update, or it may be a query, or it may be a reply as well. This is just a number, just to notify these 3 packet types. Clear? Now, so this is your neighbor table. Any doubts in neighbor table? Yes? Yes? Yes, online guys, clear? So we have one more table called topology table. How to check the topology table? It is show IP EIGRP topology. Enter. So this is your topology table. So P stands for passive, and you need to see passive only. What do you mean passive? Any idea? So
Active routes.
what?
These are the actives which should present in the routing table.
Active routes means EIGRP has calculated, and it has done its calculation. Now it is stable. Means you need to see here as passive only. So when active will come into the picture? When the successor is down and you don't have a feasible successor. When you start querying, no, you will see this state, that is active state. So you should not see this state in your topology table. Clear? Not clear? What is not clear? Why it is not why, it is by default passive. Passive means EIGRP is stable now, means there is no problem with the EIGRP routing. When there is a problem, then this P will be converted to active. Let us consider we have lost a successor or we don't have a feasible successor. Then it will start querying, right? So I don't have a successor and backup, what is the primary best path and the second path as well. Then what the router will do? Router will put this state in active state. Then it will start querying. So we should always see passive here, means it is stable. So this is your network. This is your successor, means can you see here one successor? If there was a feasible successor, if it satisfies your condition, feasibility condition, then you will have a feasible successor. That we'll see in the next lab. So we'll concentrate on this entry. So P passive, this is 2.2.2.2/32, and we have one successor. So this is the feasible distance. What is the feasible distance? Total distance from source to destination. This is how to reach, that is the neighbor IP. First represents your FD and second represents your AD. Advertised distance. And this is how to exit it out. Exit interface. Yes, Vinod? Vinod? Yeah. Now, final table. That is your routing table. Show IP route. Show IP route EIGRP. If you want to see only EIGRP routes. So why D here? Destination. I'm talking about this is EIGRP. I'm seeing EIGRP routing table. Why it is showing it as D? If you talk about OSPF, no, it will show you as O. If you talk about BGP, it will show you as B. If you talk about RIP, it will show you as R. But why not E here? Why it is showing it as D? It's EIGRP, right? What is the abbreviation for EIGRP? It's Enhanced Interior Gateway Routing Protocol. What is the first letter of E? Why not E? Why D? Interview question. Yes. No? Is anyone online?
It's already taken by.
Very good. Which protocol? EGP protocol. Good. Because E was already taken by EGP. Now we are not using this protocol. We don't have this protocol now. There's an old protocol. EGP. Now you can't give what you say E again for EIGRP as well. So they change it to D. D stands for dual. Based on the algorithm EIGRP uses. So that's why we have D here. Because E was already taken by the protocol EGP. EGP stands for Exterior Gateway Protocol. Now this protocol we don't have. Don't ask why it is not there. It has gone.
And sir, it stands for dual. So it which respect it is assigned to this as a D.
Yes, correct. Because E was already taken. Otherwise, they would have given it as E. E was already taken by a protocol called EGP. Clear?
Is it like EGP is already taken E, or is
Yes.
it a dual protocol? Wow.
No, no.
So
no.
which?
Wow. No, I didn't get you. So see,
No,
so
I
both
heard-
protocols you can't give the same name, right? E we can't
I
give
heard no. I heard two things.
It's a dual protocol. That's why we call it as D,
No.
or is it
That is
a
wrong. You can
EGP?
check in the internet or in the Wikipedia and Cisco book. They have mentioned this. Why we are not using it as E is because it was already taken. Then you tell me what OSPF uses? Dijkstra algorithm, right? Then it should be D here also. What BGP uses? BGP uses best path algorithm. Okay, that is fine. What about RIP? It uses Bellman-Ford algorithm. Why it is not B then? Correct? It uses Dijkstra algorithm. Dijkstra, our shortest path first. Then what is the abbreviation for Dijkstra? It is D, right? And why O? If we talk about RIP, it is Bellman-Ford. Then it should be B, right? Why it is R? Correct? So the very simple reason is this E was already taken by EGP protocol. So they gave it as D based on the algorithm. Very simple. Clear?
And the algorithm here is dual algorithm.
Dual algorithm, correct. You are right.
Okay. Okay.
Okay, fine. Now, so this is your AD value. We have two AD values I told you. One is 90 and one more is 170. When you will get the 170 part? When you have an external route. This is your metric, that is feasible distance. This is your neighbor. This is the uptime. This is the exit interface. This is the administrative distance. This is the feasible distance. This is the neighbor IP. This is the uptime. And this is the exit interface. Means from which interface I can reach 2.2.2.2. Can you see it? O for OSPF. BGP you can see somewhere. D for EIGRP. Can you see it? B for BGP. Done? Now. So if you want to check the K values or the router ID and all, you need to use the command show IP protocols. Now to view your K values, now to view your router ID, you can check this command show IP protocols. Even if you want to see how much by default EIGRP supports equal cost load balancing, you can see here. You can see the AD values as well. So more information you will get from here. And which networks you have advertised, everything you can see with this command. Enter. Now. So come to EIGRP. Can you see the K values here? By default, K1 is 1 and K3 is 1. And autonomous system number we are using is 12. So router ID can you see here? It is 11.11.11.11. Manually assigned. If I don't assign manually, then if I don't assign this manually, then
Highest in loopback.
highest interface loopback. If loopback is also not there, then highest interface IP address. Done? Don't worry about this. This timer will come into the picture when we have SI query and SI reply. Leave this. I'll talk about that active timer later. So this is your internal EIGRP 90 and external can you see here? It is 170. So by default, maximum paths for load balancing is 4, but it will support up to 32 points. Please make a note. So by default, load balancing, it supports 4 paths. But maximum paths, you can go up to 32. By default, it supports load balancing for 4 paths. Means it can load balance by using 4 paths to reach to the destination. So if you want more, then you need to execute a command. And it supports up to 32 paths. You can load balance up to 32 different paths. Talking about equal cost.
So by default, it is 4 and we can do up to
Up to
32,
30.
right?
Yes, very good. Yes, correct. You are right. And this is your hop count. By default, it is 100. Supports up to 250. But Cisco recommends to use only 50 routers inside a single autonomous system number. Even if we talk about OSPF area, inside a single area, we can use 50 routers. We'll talk about area when we discuss about OSPF. Done? This is the variance. This I will discuss when we are discussing about unequal cost load balancing. This is by default one. Please make a note. Variance. I'll talk about variance. What is variance? Why we use variance?
What is the maximum path? 4 is default and what is maximum?
Maximum is up to 32. You can load balance.
32.
Yes,
Okay.
yes, yes. So automatic summarization is disabled, and same thing again, maximum paths 4. So these are the directly connected networks that are advertised under EIGRP. This is the source. This is the neighbor IP, distance, and the uptime. Again, it is showing internal as 90, external as 70. Same information. Now this part is clear. Now
This command, how you check? Show.
IP protocols.
With this, we can also check what are the local routes are advertised, right?
Yes, yes, yes. You can check. Can you see
Show IP protocol.
protocols? Yes, this is the command. And if you want to check the bandwidth and all, you need to execute this command. Show interface, interface. Want to check the bandwidth, delay, load, reliability, MTU. Show interface Z0 bar 0. Can you see here? We have M2 information. We have bandwidth information here. We have delay. We have reliability, and we have load here. Yes. Yes, router and configure. Yes, yes, yes. When you will find the duplex part as well. Auto link, auto duplex, everything. ARP timeout. Done? Now. Okay. So now we'll talk about equal cost and unequal cost load balancing. So by default, EIGRP supports equal cost. So let us consider we have R1, we have R2, we have R3, and we have R4. So this is the topology we'll be designing. So we have R5. Take a loop back. /32. This is the network will be 192.168.x.x/24. This will be 12.0/24.1.2. This is 25.0/24.2.5. This is 13.0/24.1.3. This is 35.0/24.3.5. This is 14.0/24.1.4. This is 45.0/24.4 and .5. So if the feasible distance is same via R2, via R3, via R4, so by default it will do load balancing on all the three paths. First, we'll execute this, then we'll see how to do unequal cost load balancing. Okay, done? Not done? No. This is a substitution. Don't confuse with x dot x. X dot x means x is for 12 and this x is for 0. Done? You know, done? Okay, all right. So we'll see equal cost first. So by default it does. No need to change any variance or metric or something like that. So in the lab, in the same lab, we'll see unequal cost as well. We'll take 1, 2, 3, 4, 5 routers. R1, R2, R3 and R4, and we have R. Let us consider the EIGRP ASN as 1. So IP address 168.12.0 between R1 and R2. This is 25.0. This is 13.0. Thirty-five dot zero, 14.0, and we have 45.0. And we have a loop back on R5, that is 5.5.5.5 slash 30. Configure our IP addresses on the notepad, then we'll copy this. Config host name R1. Interface 0/0. The IP address will be 192.168.12.1. This is dot 1. This is dot 1 on all the interfaces. This one is dot 2 on all the interfaces. This one is dot 3. Dot 4. Dot 5. Start dot 1 /25. Motion. 0/1. So the IP address will be 192.168.13.1. We have one more interface, that is 0/2. That is 14.1. So how to enable EIGRP? So router EIGRP. So EIGRP router ID. 1.1.1.1 will take the router number as your router ID. So if it is R1, is 1.1.1.1. If it is R2, it is 2.2.2.2. So and then advertise the directly connected networks. That is 192.168.12.0 network, 192.168.13.0 and network 192.168.14.0 and no auto sum. This is the configuration on R1. I'll share you the notepad. So on R2, so interface Z0/0, 192.168.12.2. So Z0/1 will be 25.2. We don't have Z0/2 interface. So enable EIGRP. Tomorrow one more task for you guys. I'll let you know at the end of the class. So we have 12.0. We need to enable on 25.0. No automatic sync. So this is the configuration of R2. So now on R3, so Z0/0 will be 13.3. And Z0/1 will be 35.3. Router EIGRP1, router ID will be 3.3.3.3. And you need to advertise 13.0 and 35.0. No automatic. This is the configuration on R3. So on R4, so Z0/0 will be 192.168.14.4 and Z0/1 will be 45.4. So router EIGRP1, so router ID will be 4.4.4.4. So you need to advertise 14.0 and 45.0. Now final configuration on R5. So Z0/0 will be 25.5. So Z0/1 will be 35.5. We have one more interface, Z0/0. IP address will be 192.168.45.5/20. You have a loopback. IP address will be 5.5.5.5/30. So router EIGRP1, router ID will be 5.5.5.5. So you need to advertise 25.0 35.0 and 45.0. 192.168.35.0 and the loop back. Sorry, it is 5.5. I will copy paste. Copy paste. Marva. R2. Non R3. On R4 and on R5. No? No. How to check whether a neighbor distance is up or not? Show IP, EIGRP neighbors. How many neighbors I should find on our, sorry. How many neighbors? 3 neighbors. You see, I have 3 neighbors. One with 14.4, one with 13.3, and one with 12.2. Clear? Clear, Vinod? Go to R5 and check the neighborship. How many neighbors again? 3 neighbors. Show IP, EIGRP. Neighbors. I have 3 neighbors. Fine. How many neighbors on R2, R3, and R4? 2 neighbors. Good. I check on R2. Show IP, EIGRP. Neighbors. 2 neighbors I have on R2. On R3 also, I have 2 neighbors. Show IP, EIGRP neighbors. One with R1 and one with R5. Go to R4 and again you will find show IP, EIGRP neighbors. It's done. Now check the topology table. So go to R1. First we'll check the topology table, then the routing table. Show IP, EIGRP topology. Concentrate on the 5.5.5. Can you see how many successors we have? 3 successors. Why? Because the metric is same for all the 3 paths. Can you see here? This is the feasible distance. By default, EIGRP does load balancing. Go and check the routing table. Clear? No? That is fine. Okay. Now show IP, route, EIGRP. Wow. Can you see? By default, EIGRP will do equal cost load balancing. It is taking all the 3 paths in order to reach to the destination 5.5.5.5. Clear enough? Clear? Clear online, guys? So by default, it supports 4 paths. Clear? Online, guys, is it clear?
Yes, sir.
All right. Now what do you mean by unequal cost? 1 minute. Sorry. Unequal cost load balancing. Anybody has any idea what do you mean by unequal cost load balancing? Finish with 5 more minutes. 5 or 10 minutes max. Yes. What do you mean unequal cost? That is fine. But what do you mean by load balancing? It will be unequal, correct? That is what you are telling unequally. I have written it already here. So why we call it as unequal cost load balancing is bringing your feasible successor. Somebody has texted. Change in delay or bandwidth. Correct. That is fine. You are telling how to do. Okay, you are right, Mainak. So bringing your feasible successor from the topology table into the routing table. So where is feasible successor present by default? In the topology table. By default, it will not load balance. So in order to load balance this feasible successor path and bring that path into the routing table, we call it as unequal cost load balancing. Done? Done? Okay, now. So now you can change, as Mainak said, you can change either bandwidth or delay. Or if you use separate interfaces, like let us consider R1 to R2, I'm using Z0 bar 0. So in GNS3, it supports F0 bar 0 and E0 bar 0 as well. You can do that. But since in EVNG, it supports only gigabit. So I'll just change the delay. We'll go to our R1 and change the delay of Z0 bar 1 interface. So how to change that? Command is delay, and you can provide the 100. Enter. So now clear IP EIGRP neighbors. Once clear that, then go and check the topology table. Show IP EIGRP topology. Now concentrate here. Can you see what it is saying? I have only 2 successors. So what are the 2 successors? 12.2 and 14.4. So by default, now it will take 2 paths to load balance. First 2 paths. This is your feasible successor. Why? Because it has successfully, what is it? Satisfied your feasibility condition. What is the feasibility condition? AD of feasible successor should be less than FD of successor. So this is your feasible successor backup path. So by default, what is present in your routing table? Show IP route EIGRP. Only your successors. Can you see? It is using only 2 paths, 14.4 and 12.2. It is using this path and it is using this path. Now, this is the feasible successor. This is the successor. This is the successor. Clear? Now, what do we mean unequal cost load balancing? Bringing your feasible successor route from the topology table to the routing table. Now, how to do that? So now you need to configure a parameter called variance. I showed you by default, the value is 1. Now, how to calculate this variance? Variance is feasible distance of feasible successor divided by feasible distance of the successor. This is the formula to bring your feasible successor route from the topology table into the routing table. And you need to go under router EIGRP process. Then you need to mention the variance value. Router EIGRP, ASN, and variance, and the variance number. Done? Okay. Okay. Now calculate the variance first. So go to R1, go to the topology table. So please calculate and let me know the variance. Show IP HRP topology, open the calculator. Please calculate. So what is the feasible distance? It is 156416 divided by 131072. Let me know the answer. Please use the calculator to divide. It is 156416 divided by 131072. 131072. How much? 1.196. Always you need to round it off to the next value. Never use 1. Always use. By default, it is 1. It is not load balancing, right? By default, your variance is 1. So never use 1. You should round it off to next bit. It is 1.1.196. Okay, round it off to 2. Okay. Now how to configure this? You need to go under EIGRP and enable variance. So config T. So router EIGRP 1. The command is variance. What is the variance value? It is 2. 1.19. Round it off to next one. Okay. Enter. Now clear? EIGRP. Now check the topology table. Show IP EIGRP topology. Enter. Can you see how many successors now I have? 3 successors. Clear? Now it is using all the 3 paths to send the packets to the destination. Show IP route EIGRP. Can you see? Now it is using all the 3 paths. This is how we do unequal cost load balancing using variance. So anybody has any doubts still here? I'm done for the day. I hope it is clear, guys. Clear? What do you mean unequal cost load balancing? Bringing your feasible successor route from the topology table into the routing table. For what purpose? For load balancing. I hope it is clear.
Sir, for example, if there was another route and
Another feasible successor you're talking about?
no, meaning if there was another route, yeah, and if it did not meet this criteria, means it's
It will be a possibility.
okay.
I'll show you one more thing. This is not required for you guys, but we have one more command. Show IP EIGRP topology. We have possible routes. I don't think so. It is support. All links. This will show you even the loop paths as well. So let us consider it has not elected the. It has not. Suppose let us consider a path has been not elected as a feasible successor. That path will also show using this command. You can check. Show IP EIGRP topology only, but not required. So why it doesn't install that path into the routing table is it may cause loops. So it must satisfy the condition, that is feasibility condition, in order to elect as a feasible successor. Clear, Balaji?
Yes. Okay. Okay.
Any other doubts, guys? Anybody has any other doubts? Yes, Vinod, Atira. No. Okay, guys. So today we'll end up. So we'll meet tomorrow. Bye, guys. Have a nice day.